Hi everybody, today we're going to have a look at a moving averages seasonal index type problem. Here's the data we've been given, some sales data, some moving average data, and we're going to pretend that we don't know these three values here. And we're going to find those out later. Now the first thing it's asked us which moving average has been used. Well, it's a 5-point moving average. This first data point here is used 1, 2, 3, 4, 5. But we don't have any here because we can't go back any further. And it's quite a sensible moving average because it's a working week. So it's calculating the sales over a working week. What purpose do moving averages serve? Well, they smooth data to examine trends and we use them for prediction. We're going to do both in this question. Is linear regression an appropriate model for T and M? Well, T is the time period and M is the moving average. So on our little table here, we've got the periods at the front, then our sales, and then I've made another column here for the moving average data because it just makes it easier to graph. So that number's the same as that one all the way down to here. Here's the moving averages, just like on here. And we're going to look at it for a trend. So let's graph it. There it is there. And then we can do a regression line. And we can see quite clearly that it's a strong correlation. It's a strong negative linear correlation because we used a line model. And if we want the equation of the line, it's negative 0.05 t plus 3.71 because the points on here are all moving average points. So I've used m for moving average. The trend is obviously downwards. Now it's asked us for the seasonal index. We're going to have to go through our table here. Now we've been given Monday, Tuesdays, and Wednesdays seasonal index, but we need to work out Thursdays and Fridays. To find out the seasonal index is a bit of a palaver. We've got to get a seasonal proportion for each position in the cycle and then average it over a number of cycles. So here's the average over one cycle. So if you add those up, divide by 5, you get this value. And then if we divide that by our average, it gives us the index for Monday. And then we divide that by that, get an index for Tuesday, and that index for Wednesday. And then we find out the average of the second week and repeat the process, the average for the third week and repeat the process, and then find the average for all the Mondays. And that will give us the first one. And then find the average for the Tuesdays. That finds the average for the second one. Then find the average for Wednesdays. And then the one for Thursday is 0.75. So it's smaller than the weekly average and even smaller for Fridays. So here they are here, written to a couple of decimal places. Now, if we're going to predict the average for Monday of week 4, which we haven't got, we'd have to go down this line to week 4 and then apply the seasonal part, which in this case would be up by 160%. Now, unfortunately, we can't do it with this line because it won't let us do it. So what we're going to have to do, that has given us the equation down here that we're going to use, go to graphing mode and use this one, which I put in here earlier. There it is there. We're going to have to change the graph to show us what we want it to show. We want from 0 to 17 because we know we want the 16th period. There it is there. Go into trace mode, type in 16 and find out that the y value is 2.18. So once we know that it's 2.18, we'll write it down. That's what the moving average point would be for that day. Multiply it by the seasonal index for Mondays. So it's 154% of whatever the weekly average is. And in this case, it would be 4.339. Now, because it wants it to the nearest $100, and this was in thousands, it would be $4,300. That would be the sales that we'd expect for Monday of week 4. And if we comment on the reliability of the prediction, given that the trend doesn't change, because if the trend changed, the prediction would be useless because we're using extrapolation. The result would be reliable as it's in close proximity to the data given. We're not going a long way away, so extrapolation in close proximity to the data set is going to be reasonable. Well, I hope that helped. There was a lot in there. I obviously don't expect you to learn it from this, but it might be a good reminder if you're using this video in particular just prior to an assessment. I hope that's helpful, and I'll see you all soon. Thank you.